Okay, here's a video for 12-2 and 3. I'm first going to show you the worksheets, the exploration activities that we did in class in case you missed a day and you need to fill in any of the blanks. For the first challenge on 12-2, this is what the picture should look like. Okay. If you want to spend some time and actually draw this and measure it out, you can fill in the blanks here if you want. But what's most important is this rule right here. Okay, this is what's important in that challenge. Okay, in the next challenge we had the same picture. All we did is take the converse of that rule. Okay, so we just reversed it, but it's the same theorem, it's just reversed. Okay. Then for challenge 3, you are doing both of them and you were supposed to find out that they go to the center, so the blank for that one is center. And then I added 2 challenges to this one. We did 2 congruent chords and we found out that they were the same distance from the center. Equidistance means the same distance. So if the yellow is equal, then the orange is equal, and vice versa. If the orange is equal, then the yellow is equal. Okay, I color-coded this so hopefully it'll make sense when it comes test time. Okay, then we did challenge 5. Again, we started with congruent chords and we measured the angles to be congruent. If the chords are equal, then the central angles are equal, and vice versa. If the central angles are equal, then the intercepted chords are equal. So yellow and pink have to match. Alright, then 12-3, we had challenge 1 that said if you have a chord, 2 inscribed angles will be the same. So it's equal. We didn't do this one, but we did fill in the blanks. That one is also going to be equal. Then we had challenge 3. This is a really important one. Okay, this one is going to show up a lot. Okay, so challenge 3. The inscribed angle is going to be, or the central angle is going to be twice as much as the inscribed angle. So the middle one will always be twice as big as the one on the edge. Or another way to say it is the inscribed angle will be half of the arc that it forms. Okay, remember the arc and the central angle are equal. Okay, I'll go ahead and write that on here too because somebody said it was not in the vocab video. Okay, so the central angle and the arc are always equal. Okay, and then the inscribed angle will be half of this or this, either one. Alright, we also wrote this down. So the blank is twice, but we also wrote this sentence down demonstrating this picture. Okay. The answer to that one was 90. Here's the picture for it. And then we had challenge 5, which is pretty self-explanatory. If you have a quadrilateral, the opposite angles are going to be equal when it's inscribed inside of a circle. I promised you some examples of this. What is this going to look like when you apply it? That's the only thing we didn't do in class is apply. And that's what we're doing tomorrow. Okay. So, for example. Okay. Okay, if I have that picture, okay, they want to know what X is. Okay, well, what do you know about your chords? What is the length of that chord right there? It's 36. Well, they also tell you that this length is 36. So this goes back to 12-2, challenge 4, the one that I added. If the chords are equal, what do you know about their distance from the center? It is also equal. So just applying the theorem, because of 12-2, challenge 4, x equals 16. Okay. Here's another example from this one. That's a radius. That's a chord. And this one is perpendicular. That's another radius, except it doesn't go all the way to the edge of the circle, but it is perpendicular to the chord. Okay, they tell you this is 6.8. and they tell you this is 4. Okay? I want to know the length of the chord. Now, they're already telling you that this is a 90-degree angle. And we have a right triangle. Okay, 6.8 is your hypotenuse. So we can do Pythagorean theorem to find this length right here. Okay, and we'll call this x. So it's x squared plus 4 squared equals 6.8 squared. You can either do this by hand. I don't know what 6.8 squared is. $46.24. Okay. You could also do an insolve with this. You just type the whole thing into insolve and solve it. But I'm going to go ahead and show you the by hand stuff. Okay, so 46.24 minus 16 gives you x squared equals 30.24. Don't forget to take the square root. Okay, and I get x equals 5.499. But is that my answer? And the answer to that is no. All you found was this. The question asked for the chord. So that is the length of the chord. This goes back to our theorem. Okay? This is 12-2, either challenge 1 or 2. Technically, I think it's challenge 2. That says if it's perpendicular, then we know that it goes to the midpoint. So that means this section is equal to that section. So all I have to do is take my x and double it. So double the x. So 5.499 times 2 equals 10.998. Okay? It's pretty simple. So that's 12.2, some examples from 12.2 and 12.3. Or, I mean 12.2. Let's go to 12.3. Okay. Okay, so you'll have lots of pictures like these, and these actually will start to get really fun because they're like a little puzzle. One thing you need to understand is when you see a degree outside the circle, that is talking about an arc. So that 30 degrees is talking about that arc right there from T to F. Okay? I do give you a center, but none of the lines go through it. Okay, and we're supposed to try to find all of the other variables. So we're trying to find arc A and arc B. And just looking at this picture, I really don't think that 30 degrees is going to be used, but it might. Let's look at it. We know that arc A starts at this point and goes all the way to this point. And if you notice, this inscribed angle right there intercepts that arc. So, according to challenge 3, 12-3 challenge 3, this should be half of the arc. So to find A, I have to double it. So A is going to equal 60 times 2, which is 120. Okay. Now, I also noticed that there is another inscribed, oh no, we will use the 30, I see. Alright, so inscribed angle B starts at this arc, or this point, and ends at this point. So that takes us from P all the way around to S. The total of that arc, okay, if we're just using addition, this was 120, and that's 30. So arc PS, notice how I'm doing my symbols here. When I talk about an arc, I just use the endpoints and draw a little arc on top. So measurement of arc PS is equal to 120 plus 30, which is 150. And angle B is the inscribed angle that forms that arc. So to find angle B, I'm just going to take the 150 and divide by 2, which gives me 75 degrees. The biggest challenge is remembering when to multiply and when to divide by 2. If you're going to the arc, you're getting bigger. If you're going to the angle, you're getting smaller. So this way is bigger. Think bigger. Oh my God, I couldn't see that. So from the angle, you're getting bigger, so that's going to be multiply. And if you're going this way, it's getting smaller, so that's going to be divide. I'm doing another one. In this one, we're just trying to find angle 2. Okay, trying to find angle 2 on this one. Okay. So, I noticed that this inscribed angle uses that arc right there. So if this is 38, to get to the arc, I double it. So 38 times 2 is 76, I believe. I'm going to check myself just because my brain's not functioning right today. 38 times 2, yeah, 76. Alright, so this arc is 76, but if you notice, this inscribed angle uses the same arc. Well, if it's the same arc, then they have to be equal. So measurement of angle 2 also has to equal 38 because they use the same arc. And that is actually challenge 1. 12-3, challenge 1. So you get the idea. I'm just going to show you one more thing and then we're done. Okay. It is possible to have an inscribed angle with half of the angle outside the circle. Okay. But it only works when I have a tangent line. Okay. This is still an inscribed angle because the vertex is on the edge of the circle. And it still has an intercepted arc. Okay? So the arc from here to here is still the intercepted arc. And the angle from here to here is still the inscribed angle. So, for example, if you knew that this arc was, and it looks like it goes through the middle, but let's say it's a little bit more than the middle. Let's say this is 190 degrees. Let's say the center is right there. Okay. Let's say that's 190 degrees. Then this angle right there, the yellow angle, would be half of that. The same rule that you saw in challenge 3. It just looks a little bit different because half of your inscribed angle is kind of hanging off outside the circle, but it's still the same rule. You're still going to do 190 divided by 2, which gives you 95 for your yellow angle. Okay, so just keep that in mind for the homework.